Hi, I'm Tom from Emergency Professor, and today we're going to be going over factoring polynomials. There are 5 major ways of factoring polynomials. The first is just removing a common factor. The second is by grouping. The third is factoring the formula x squared plus bx plus c, the form of a polynomial. The fourth is factoring ax squared plus bx plus c, where the a is not equal to 1. And then the fifth is where we'll factor special products of polynomials. And that's pretty much just memorization. So let's get started. So first we'll do the common factors. And we'll start with an example. We have 20 plus 10x plus 15x squared. 20 plus 10x plus 15x squared. Here we see that there's a 5, which is the common factor in this number. And so we'll rewrite these as 5 times 4 plus 5 times 2 x plus 5 times 3 x squared. So we can rewrite that as 4 plus 2x plus 3x squared. And so we factored out a common denominator. So with grouping, we just rewrite the polynomial. So we use the example of x cubed plus 3x squared minus 5x minus 15. So we see that we have a 1 and a 3 and a 5 and a 15. So and we also have x squared and x cubed here. So by grouping these two terms together and factoring out our common factors, we can come to a solution. So here it's x squared times x plus 3 minus, when I put the parentheses around that, I should have changed the sign from plus to a minus. Hopefully you understand that. Minus 5 times x plus 3. So we have x plus 3 and x plus 3. So the answer is x squared minus 5 times x plus 3. Okay? So our third method is where we have the x squared plus bx plus c. So we use the example of x squared plus 5x plus 6. First we're going to see if there are any common factors, which there are none. Then we look at the c factor, and we want to find numbers where their product is c, or in this case 6. So this is a c, if you recall. And we want to find numbers where the product is c, in this case 6, and where their sum is b, or in this case 5. It can be the product of either, 6 can be the product of either 1 and 6 or 3 and 2. So this could be 1 times 6 or 3 times 2. But the sum of 1 and 6 is 7. 1 plus 6 is 7, so that's not right. And the sum of 3 and 2 is 5. That's equal to 5. So that would be the solution. So we'd get x plus 3 times x plus 2. If we use the FOIL method and multiply these, FOIL being the first terms multiplied together, outside, x times 2, inside 3 times x, last 3 times 2. And that is x squared plus 5x plus 6. Let's try another one. So our next one is 2y squared minus 14y plus 24. Of course, we're doing the form x squared plus bx plus c. That isn't in that form. Here we have y instead of x. So we need to factor out the 2's if possible, and of course we can. 2y squared minus 7y plus 12. Okay, so we're looking for two numbers multiplied together, and would give you 12, and when they add, they would give you a negative 7. So obviously, to be a positive 12, the two numbers would have to be both negative or both positive. But if they're both positive, when you add them together, they're not going to be a negative. So we know our numbers have to be negatives. So negative 4 and negative 3 times each other give you 12. and negative 4 plus a negative 3 added together give you 7. So our solution should be 2y minus 4 times y minus 3. And in fact, this would be y squared plus outside and negative 3y plus the inside negative 4y, that's a negative 7y, and the last would be negative 4 times a negative 3, which would be a positive 12. So now we're going to go to the next, with the fourth method, which is trinomials of the form ax squared plus bx plus c, where a is not equal to 1, because we just did that. One method is to use the reversal FOIL method. FOIL stands for first, outside, inside, and last. And using the two terms x plus p times x plus q, we would get, for our first, x squared. For our outside, x cubed. For our inside, px, and for our last, p. Putting the terms together with a little grouping for the outside and inside terms, we get x squared plus outside plus inside plus last. And we know that we can rewrite that as x squared plus q plus p times x plus pq. So we know that p times q and p plus q, these two numbers, would give us the solution. So let's say we try that on x plus 2 times x plus 3. So x plus 2 times x plus 3. First would be x squared. Outside would be 3x. Inside would be 2x. And then the last would be 6. We put the terms together and we get x squared plus 5x plus 6. So to solve the trinomial of the form ax squared plus bx plus c, where a is not equal to 1, we first have to make sure that the largest common factor has been factored out. Then using the reverse FOIL method, we need to find a solution, mx plus p times nx plus q, such that the coefficients m and n of the first terms, mx and nx, when multiplied are equal to a. In other words, m times n equal a. Then the outside term coefficients are multiplied and added to the product of the inside terms, such that mq plus pn equal b. So mq plus pn is equal to b. And finally, the last terms of the factor solution, pq, must be equal to c. So let's use the function 3x squared minus 10x minus 8 to illustrate. So we have x plus a number times something times x plus a number is equal to 3x squared plus minus 10x minus 8. Obviously the first two terms will have to be the same, some combination of 3 and 1 to get to 3x squared. So let's just plug the 3 in there and the 1. Start with that. The last two terms must be numbers that are equal to a negative 8. So the possibilities are negative 8 and a positive 1, positive 8 and a negative 1, negative 4 and a positive 2, positive 4 and a negative 2, and then negative 1 and a positive 8, positive 1, negative 8, and then the reverse of these. So this is kind of a long method, but we have to go through each one unless you kind of intuit numbers that might work. So let's see. If we recall, negative 8 times a positive 1 will give us a negative 8. But what we need to do is multiply using the FOIL method. With the FOIL method, we get the outside 3 times a positive 1 is a positive 3, and the inside, negative 8 times 1 is a negative 8. That's a negative 5. So that doesn't work. Again, outside, 3 times a negative 1 is a negative 3, and then 1 times a positive 8 is a positive 5. Neither of these work. 3 times 2 is 6, and 1 times a negative 4 is 2. And 3 times a negative 2 is a negative 6, and 1 times a positive 4 is a negative 2. We're not there yet. 3 times positive 8 is 24. We don't even have to go there. It's so far away. And this will be a negative 24 plus something. We said 3 times 8 and 1 times a negative 1. Minus 1 plus 1. 23, negative 23. That's not it. Looks like we have only 1 or 2 choices left. 3 times a positive 4 is 12. And 1 times a negative 2 is equal to 10. But we need a negative 10. So 3 times a negative 4 is a negative 12. And 1 times a positive 2 is equal to a negative 10. So our solution is here. So that's 2, and this becomes minus 4. And that's using the reverse FOIL method. So another second method within the fourth method for ax squared plus bx plus c is the grouping method. Again, we're solving for ax squared plus bx plus c, where a is not equal to 1. Here what we want to do is multiply a times c, and then we want to factor this product so that the sum of the factors is equal to b. So if a times c is m plus n, we want m plus n to be equal to b. Use an example. So we've got 12x cubed plus 10x squared minus 8x. So we're going to factor this out. 2x times 6x squared plus 5x minus 4x. So we said we're going to multiply the a times the c. So 6 times a negative 4 is equal to negative 24. And we want to factor negative 24 so that the sum of the factors is equal to 5. So, for example, negative 12 times 2 gives you negative 24, but when you add them, you get a negative 10. How about negative 8 times 3? Well, negative 8 plus times 3 is a negative 24, but negative 8 plus 3 is a negative 5. So we actually need a positive 8 and a negative 3. That's our two factors, 8 and a negative 3. Once you've determined the two factors, you're going to rewrite this equation as 6x squared plus 8x minus 3x minus 4. Let's regroup these, and we get 6x squared minus 3x plus 8x minus 4. And we can regroup and factor those, and we get 3x times 2x minus 1 plus 4 times 2x minus 1. So we have the same factors within those. And that can be written as 3x plus 4, 2x minus 1. So now let's go to the special factorizations. Our first one is a squared minus b squared is equal to a plus b times a minus b. So, for example, x squared minus 4 is equal to x plus 2, x minus 2. You notice that the term with the x in it is not in that because outside is a negative 2x and inside is a positive x. They cancel each other out. Here's another one, a squared plus 2ab plus b squared. And that is just a plus b squared. And you'll get your outside and your inside terms, which under the FOIL method are going to be exactly the same. So it would be 2 of those. A times b plus a times b is 2ab. Our third special factorization is a squared minus 2ab plus b squared. And that is a minus b squared. Here, the little difference between this and the one before is the sign here. So we'll have the outside, which is a times a negative b, which is a negative ab, and the inside, which is a times a negative b. So we have 2 of the same terms, they're just negative this time, so it's a minus 2ab. So x squared minus 8x plus 16 would be x minus 4 squared. Our fourth special factorization is a cubed plus b cubed, and that can be factored out as a plus b times a squared minus ab plus b squared. X cubed plus 8 would be equal to x plus 2 times x squared minus 2x plus 4. And then a cubed minus b cubed can be rewritten or factored out as a minus b times a squared plus ab plus b squared. And here, x cubed minus 8 is equal to x minus 2 times x squared plus 2x plus 4. Note the difference in the signs. And that's our methods for factoring polynomials. We'll follow up now with a long slew of problems that we'll be solving. So stay tuned. Thanks.